Hi guys, and welcome to the presentation. We're doing differentiation using the quotient rule. It's a really cool tool whenever you have a function on top of a function, and they're two simple functions that we wanted to find the derivative to. And how does it go? Well, if you got u on the top and v on the bottom, u representing the numerator, we're going to label that up as black, and the denominator there in blue. Now here's the formula, the rule: dy dx equals v times du, in other words u dash, minus u times dv, in other words v prime or dash, all over v squared on the denominator. So let's go ahead and do this. One of the best things we can do is first label up what we have over here and then substitute into the rule. But first we need to have an example. So here's the example that we can actually derive, or find the derivative, sorry. There it is there. We have y equals, the function on the numerator is 4x cubed minus 5x plus 3, and on the denominator x cubed minus 1. Now that's all in blue down there, and I'm going to write this out, the rule, using blue and black to help emphasize and highlight where each component goes. So first up, I'm going to put that red line down here to mark up exactly what each component is. So first up, let's write up what u is. Now u is going to be in black because it's the numerator, so our u is right there in black, so we just copy that out. It's 4x cubed. U equals 4x cubed minus 5x plus 3. Let's call that du. Du, or u prime, whatever you prefer. If we differentiate that, we get 12x squared minus 5, all in black. Let's write down what v is. Now our v is the denominator right there, and that's x cubed minus 1 dv equals 3x squared when we differentiate. Okay, now we can just slot and substitute them into that rule. Let's do that across here. It's going to be quite long, and there's quite a bit of expanding, so we're going to be really careful with our substituting. So let's go ahead and do this. The first up, we start off here with v in blue. So here's our v, x cubed minus 1. And we multiply that by du right there. Let's find du. There it is, 12x squared minus 5. And we subtract, as it says in the rule up there, and we have u times dv. Where's our u? There it is right there. I'm going to put some parentheses there to ensure we don't make any errors. So we take it bit by bit, 4x minus 5x plus 3, and we multiply that by, here, by 3x squared by dv. Okay, all of that is over. There are many carriages to this. The denominator there, which is x cubed minus 1, and of course we square that because it is v squared, isn't it? So okay, we've got that. Now I'm just going to go and write everything in black. I'm not going to separate the colors, so it's simple to follow, but you know which part, where they come from. So that's the quotient rule. Let's go ahead and find dy dx. So expanding this using the FOIL method, x cubed times 12x squared. The powers, we add them, so 3 and 2 is 5. You already know that. So let's go ahead and do that. Minus cubed minus 12x squared, and negative and up, negative is a positive, so that's plus 5. Okay, then we subtract, parentheses, 4 times 3 is 12, x to the 5 minus 15x to the power of 3 plus 9x squared all over Same as before. Okay, we can further simplify this when we get the y dx. Let's see what we can do. Well, essentially, we can actually rewrite this, and that's going to be a minus here. So let's fix the sign. So that's a minus. And because we've got a minus here, that will change to a plus. And we had a minus there, that's going to change to a minus. Subtract right over there. Okay. Now that looks correct, so let's see if we can collect and eliminate like terms. So what like terms do we see? Well, we've got 12x to the 5 here. We can cancel that with negative 12x to the 5 right there. Any other terms? Well, we can collect negative 5x cubed with positive 15x cubed. Let's add them together. That's going to give us altogether 10x cubed. Let's see. Take away 5 from 15, x cubed. All right, we have a negative 12x squared and a negative 9x squared together. That makes negative 21x squared. So they're eliminated. We've got this 5 sitting there. Let's bring that down here. Okay, that looks like the numerator, 10x cubed minus 21x squared plus 5, all over the existing denominator, which is x cubed minus 1 all squared, and that is our derivative.